Professor Thomas Franke give the next talk. He was also our previous, do we say president, spokesperson, or spokesperson for the Fachgruppe for Engineering Psychology. And like Martin and I were very delighted to step down. You also kind of stepped down just from spokesperson, step down from spokesperson to vice spokesperson for the engineering psychology. So I'm glad you're talking about this because this was actually a topic that I first got to know you about. I did not know Thomas until, and even then I did not know him at the Human Factors Society in Las Vegas, where they were saying, oh wow, there's this best paper award for this up and coming high flying PhD candidate with a postdoc out there. Yeah, oh yeah. So many awards, I forgot which award I won. Yeah. And he was doing his PhD in PU candidates at that time. So that's when I got to know about you and I thought, oh wow, this is a really interesting topic. It's not just about doing something related to technology and human machine, but actually it's something that represented a real problem that no one thought about in society if you want to even adopt electronic vehicles, right? Range anxiety and how we usually make decisions. So I'm glad that you're talking about this. Yeah, what else can I say about you except that I really like you? No more, yeah? Okay. Okay, well, we look forward to your talk, yeah?
Thank you.
Yeah.
So a bit like on the topic, maybe that's a suggestion, what could we mean with technology for good? Maybe we go to the driving domain, which is for some kind technology for good, for another way, maybe not. But let's look at it from a specific perspective, and Louis came up with this title, and I just adopted it. It's Interfaces for Sustainable Eco-Driving Behavior. So yeah, I'm a professor of engineering psychology at University of Lübeck, but studied here and did my PhD on user interaction with the range of electric vehicles. And at this time, in the late zeros, we had the privilege here to be involved in large-scale user field trials. So people using technology that was not on the market, and we could ask them questions as much as we wanted, almost. And we published some papers on range stress, charging styles, also user preferences, how they change with experience, psychological range, and so on. And now, to make a little advertisement why it could be interesting to visit Lübeck at some point in time, for example, next year for HFS Europe, in April. Who of you has received the call for abstracts for HFS Europe in Lübeck? Okay, that's interesting. So we can figure out those who didn't receive it by that. So in Lübeck, we are a team of 5 young and fresh professors at the Institute for Multimedia and Interactive Systems, and we research the whole spectrum of topics in human technology interaction. With the research infrastructure we've developed over the last years, and always together, or very often together with the students of media informatics, or also cognitive systems now. And we do lots of research on human-centered design, integrating computer science, psychology, and design. And in the research group that I have the privilege to be head of is also focused around this intersection of computer science, design, and psychology. And we always say, okay, somehow we pursue 3 lines of research with a focus on sustainable digital resource regulation. So we say, in the end, humans have to balance 2 classes of resources, their internal resources, the mental and physical, and the external resources they utilize. And to understand these dynamics, we enter into many applied contexts such as car sharing, electromobility, shipping, on the green line here, and I will come to this today. And we also have other topics that are more in the medical health domain on the red line. And of course, we also work on methods. So be it multi-agent simulation or our driving simulator, or also maybe some of you have heard of our affinity for technology interaction questionnaire state. So we always also like to develop new questionnaire measures. And today I somehow relate to 8 projects, but maybe the projects are not so important, interesting for you, more the content. but perhaps it is still one interesting thing because, yeah, on the one hand, I would say, okay, we all would say yes, probably. It would be interesting to discuss if anyone says, yeah, that's missing something. I would say that our approach as engineering psychology is around asking always two core questions. On one hand side, what are key challenges for human resource, not necessarily human resource regulation, but for us it's human resource regulation in a certain technical or digital environment. On the other hand, how can we optimally support users in the regulation of resources via system design. And if you want to know more about the research we do, you don't have to look up Google Scholar, but you can just have a look on our YouTube channel, Engineering Psychology, where it's always in the core about one formula, which is sustainability is always a product of human and technology. So some papers presented there, I will also shortly touch here in the following talk. So just a short invite, if you like, to spend your, maybe not your train travel with the Wi-Fi on German trains, but maybe any other empty time. Okay, so today we focus on the topics of interfaces for sustainable eco-driving behavior, and I would try to first put the problem or the question here in the room, as we are living in a world of climate change, and when it comes to transport, we face the challenge to reduce transport emissions. So what can we, as engineering psychology researchers or also computer scientists working closely at the intersection or interface of near humans, do for sustainable mobility? And I would say we can support eco-driving, as an example, by guiding users towards energy efficiency, increasing awareness and understanding, and support energy-related decision-making. And why is this important? You already saw the formula, because energy efficiency or sustainability is always a product of technical potential. Of course, we need to use optimal technical systems and user behavior. So we need people to adopt, we need people to do the right usage decisions, and then we need them to have a good, favorable user system interaction. And here, specifically, I would argue that it's good to view user behavior in the field of mobility through a lens of resource regulation. What do I mean by that? Okay, in many settings of our everyday life, we are somehow regulating precious resources. So if you think about your life or right now, so what are precious resources for you? For me, precious resource right now is maybe time. Any other precious resources that you have?
Work time, because I get interrupted by the
Oh yeah,
time.
yeah. So non-interrupted time.
Coffee.
Oh yeah, coffee. Coffee is a great resource. So there's lots of things that we can think of, work-related, mobility-related. And the funny thing is that psychologically speaking, it's all the same, because no matter what resource is at hand, they are all sharing very similar psychological principles. We try to achieve resource gains and avoid resource losses. And as we all know, we are not completely rational in this, so bound rationality, for example, like prospect theory tells us losses hurt us twice as much as gains may feel us better or good. And in everyday environments, it's not a single or, it's more a continuous process of resource transactions or resource regulation. So we, for example, decide maybe in our mobility for a faster connection in exchange for a loss of money. So we opt for a greener solution and accept some flexibility losses. Let's say we take the train. We accept some security losses. We drive in certain ways to, let's say, to a preferred charger, electric vehicle charger, so that we have enough range left as to make us feel comfortable. So we trade different resources, consciously or subconsciously. And from a psychological perspective, we can view this as goal-oriented behavior or say action regulation. So it's always a mix of cognitive and motivational, or let's say motivational and volitional factors. And as you may know, we can describe such action regulation processes as a control feedback loop, So a control flip, it looks at, for example, reduces the discrepancy between something we desire and something we have. For example, when it comes to electric vehicles, let's say we desire to have a certain range buffer that we want to have, that we are sure we arrive at our destination. So here's a range buffer, and we have a certain perceived range buffer and a certain preferred range buffer, and depending on how these compare, we may use some coping, like charging en route, driving more economically, or else. So this has been applied to such contexts. Resource regulation or control theory models has also been applied to EcoDriving, so a more continuous adaptation of driving behavior. And so my first takeaway would be we should view sustainable mobility through a lens of resource regulation. And now, as I already pointed out, and here we see it on one slide very condensed, we as humans are not very good at regulating our resources in an optimal way. Instead, we are best described as individuals with bounded rationality, and we fall for heuristics, suboptimal heuristics, and biases. So optimal resource regulation is challenging for humans, so here we have our problem. And now the question is, how can we make such optimal resource regulation as easy as possible for humans? And here we end up with these projects, and I will start shortly to speak a bit about the Amori project, which has a name which also shall signify that it's one of our beloved projects. So let's say I want to drive to my favorite beach at the Baltic Sea. What's the most efficient, energy efficient way to drive the 40 kilometers to the beach with my car? Of course, the answer is I should take the bicycle. But let's say I have to take the car, for what reason ever, then the most efficient way to drive is to take to 30 kilometers route to the beach. So the problem is that our most common energy efficiency metric, which is energy per distance, gives no incentive for taking short routes. And that's the thing, the information you have available in all your cars if you drive a car. So first we should have interfaces that make us aware of the blind spot. Okay, let's say I took the shortest route, then what is the most efficient way to drive the 30 kilometers to the beach? So if you drive with a constant speed on a flat road, and now we're getting physical, it's all about rolling resistance, which is constant, but it's also about aerodynamic resistance, and that's increasing in a quadratic function with speed. So the faster you drive, the more expensive it gets to drive a certain amount faster. And on the other hand side, the less you gain from this. This is a time-saving bias, if you're interested to learn more about this. So somehow we should have something in our vehicles that helps us trade energy consumption versus travel time. Yet there's one more factor. Of course, electric vehicles, they have a motor. Motors are efficient in certain regions, and so having like a moderate speed is quite efficient in typical BEVs. So take away, choose your speed wisely. But as we all know, life is more complex than just choosing the correct speed. That's a more typical profile we have to follow. So how do humans control their behavior in such dynamic environments? And you may say, okay, that's quite a driver-centered talk. Why do we have such a driver-centered talk here? I would say we can apply this or transfer this to many dynamic situations, because in many realistic real-world scenarios, we have like a multi-criteria problem. In driving, for example, we want to get there alive in time, maybe with low stress, with reasonable energy cost, and without disturbing other factors or people around me or in my car. And drivers do this without much problems, and they continuously adapt their behavior to balance these goals. And such dynamic aspects can be particularly well modeled with control theoretic framework. And here's one, and I don't want to go into detail, I only want to go into the detail on one box, which is subjective expected utility. And here I have the next question, which is, what do safety, time, energy, and pleasure have in common? They are our resources. And as we know, we can trade resources against each other. Although resources may be different, they are subject to the same psychological principles, which is trying to achieve gains and avoid losses. And we are bound by bounded rationality. Thus, basically, we can describe the control of energy flows as an economic transaction of an input resource for an output resource. So, for example, in an electric vehicle, electric energy for distance driven, because what you want in the end is to cover a certain distance. Or you could say, yeah, maybe that's not, but let's assume that's my ultimate goal. And now a key mechanism of behavioral economics, you might be well aware of that, is that resource transactions can be framed differently. So the same resource states, energy flows, dynamics can be represented as, for example, either gains or more as losses. And any energy interface, so any information we provide to users, constitutes such a frame. So we, as people somehow in charge of how information is displayed, have quite a big power or also big responsibility. For example, in acceleration, let's say you want to drive and then you accelerate and then you ask, well, was this good? So was this even efficient? So nowadays, drivers typically have one salient information source or one salient interface, which is an instantaneous consumption indicator. You can find it almost in any car, especially also electric cars. And it also works, although it's instantaneous, on the energy per distance metric. And we found in past research, so Vivian Moore, one of her PhD papers, that people can have a peak bias. So when they look at several acceleration maneuvers, they are not in a very good position to make a rational judgment about which maneuver was more efficient and which not so much, because they overweigh the peak height of the maneuver, so of the consumption, and not so much the peak duration. And even more, so we could de-bias this. We could just not have instantaneous consumption indicator, but we can have instantaneous consumption trace. But there's more, because energy per distance is not the most accurate framing for acceleration, because acceleration, as I said before, we have to think about this economic transaction, is investing electric energy to establish kinetic energy. So the conversion efficiency in the electric motor is the key point. So how many or how much velocity can I gain per invested unit of energy? And there's such a nice graph to the right where we could deduce it at any point in time. But of course we can't show this to people in the car. Maybe we can make it a bit more usable or even a bit more usable, and it's still very unusable. But in theory, it would be a very good paper, a very good display. Yes, so, and we are examining this and other topics in our driving simulator. And if you say, yeah, okay, so who has ever always has at any time done research in the driving simulator? Okay, quite a few. So if at one point in time you become interested in driving simulators, let's get in touch. So the perhaps it's now a bit nerdy talk, but the special thing about our driving simulator, it's a real simulated digital twin of a certain electric car, and so we can have realistic energy consumption values to cut it very short. And we do studies, and as Markus is also here, I won't go too much into detail with his studies, so we can describe certain energy information framing or information provision on certain outcomes like performance, but also user experience or knowledge of situation model states. And for the few of you who are more interested in driving simulation, I just wanted to point to our poster from last week from Automotive UI. Maybe the first poster was there's a live driving simulator inside the poster. And if you're even more interested, you can also try out our driving simulator on my laptop later. So for now on, when we come back to the psychological perspective, I would say the takeaway is we need action-integrated energy interfaces, which boils down to energy efficiency metrics and indicators. maybe also some very weird stuff as this. Okay, so is there maybe even more we can do from the perspective of engineering psychology? So far we just covered more or less 1 or 1.5 bubbles from this slide. And I would say, yeah, there's one important further issue if we want to reduce transport emissions, because if we need some individual or car-based mobility in the future, and we need to have it as individual mobility or isn't relevant or individual or somehow shared mobility, then of course consuming as less energy as possible is important. But the question is also how can we make the recharging, so the replenishment of resources more sustainable. And this is what we examine our lab Renobil. So at the University of Lübeck we have like these 2 Nissan electric vehicles that have bidirectional charging. And then we have a very nice graph that we don't have to go into the detail, only it's like a real usable living lab, so we can have different charging interfaces and examine how the charging interfaces and booking interfaces, because it's integrated in a car sharing scheme, lead to different user experience and user behavior. And to do this in a very good way, we also use multi-agent simulation to create more or better or more advanced algorithms to optimize these processes, or also to cooperate with users. And we apply this in projects like, for example, our EcoShare project. And if you're interested in this, Markus Gültger, who's here, can also tell you more about this. I would skip 2 slides and come to one question which is relevant in this domain, but which is also very relevant in all other domains when it comes to interacting with, or many domains when it comes to interacting with AI, which is, now, if you can make charging optimal, and you can tell people when charging is optimal, so is telling the right approach, or is there a way to arrive at something that we could really call cooperation? So can we cooperate with an AI agent as we can cooperate with another human? This is already part of the answer to the question, how can we make it as easy as possible for humans to behave optimally through user-centered design of charging agents? And this is something we look into in our project Co-Charge together with Honda Research. I don't have to give you the full technical background, so that charging an EV, it depends if it's good or bad, based on how do I support the utilization of fluctuating renewable energy resources. But in the end, if we want to have such an AI agent that supports users, we really have to acquire a good psychological understanding of the perceived cooperativity to inform HMI design in the end. And we do this based on literature that you may already know, for example, coactive design, or more in the direction of social perception. Much of this research related to this human-agent collaboration or cooperation has been also conducted here at Chemnitz in the last years, and we apply this to cooperative card games and to charging, in the same projects. Okay, so for here it's only short glimpse, and to state the takeaway, we have to achieve a comprehensive understanding of human AI cooperation to help us design better smart charging systems. But to slowly conclude, is there maybe even more we can do? And I would say yes, because as I already pointed out a bit, we shouldn't stay with individual mobility. We have to move to shared mobility. So how do we close this gap between the very attractive, I have my own car and drive whenever I want, wherever I want, and Deutsche Bahn or something like this? For this, we partnered up with our local public transport back some years ago already, and started the project into Lübeck, which is based on a ride pooling service that has been established over the last year. So you may know, for example, Bergkönig or Moja from Hamburg, and that is something here that is not organized by a private company, but really integrated in the local public transport. And now the question is, where's the psychology here? So when it comes to mobility, of course there are things that are in this direction of the microscopic user system interaction, but what may be even more important to understand motivators of human behavior. And here we follow the line of investing research energy in basic human needs. So how can we go from this basic human needs perspective from Sheldon or also Hassensal papers to system design? And here for the field of mobility, we developed the perceived mobility needs satisfaction scale that can help to measure or assess or scale the somehow quality in the end that certain mobility services have. And we apply this, for example, if you apply this here in a questionnaire study, and then people rate this. So first this encircled area is autonomy, need for autonomy. So for example, an item would be, this service, mobility service allows me to be flexible. This is how people perceive public transport. This is how people perceive private car. You can guess right, more to the right is somehow better. And this is how they perceive Limo. The ride pooling service. So even it gives them more autonomy than their private car. And I don't know if someone can already guess why. It may have something to do with alcohol. I would say we should look at the human basic needs perspective as a good metric for example, good public transport, but maybe also good technology at all. But there's even more, and that's my very last slide, and then I conclude. Last slides I should use. And we go back to the beginning, because now we have looked at eco-driving, eco-charging, eco-mobility. So let's look again at eco-driving, because so far we have only moved on wheels. Let's move on water. So here we are on our project Maridata, and also here I don't speak about too much because Muratsubi is here. Because that's something of an elephant in the room, right? If we want to reduce transport emissions, these 50,000 ships that are around right now on our oceans, and they won't go away. It's still the most efficient way of getting things from one place to another. So we will not, like in 10, 20, 50, 100 years they will just not vanish. And they produce 3% of total carbon emissions. And as you may guess, there are really intense legislators' pressure to reduce these emissions, and also big goals and so on and so on. But the problem is, I mean, a ship, you don't buy a new ship every 5 years, 10 years. So you need something that can be implemented on ships today. So of course the ship operation is a quite important point to start with, and so we do this in a larger project, also publicly funded federal ministry, on decision support systems that we examine. So we, or let's say so far Murat, sometimes drives with people on ships, or we go in ship simulators. We have a very nice ship simulator, our partners at Flensburg. And then we can do all these human factors methods that are so interesting, but we can also work on this topic from a perspective of basic needs satisfaction. So that's my last takeaway. Decision support systems can support energy efficient management or efficient energy management on ships. And that's it. Thank you for your attention.